while you are there login and making sure that the system recognizes for your first login, I would like to discuss for 15 minutes what are the things that you learn during the TPCDS project. I mean, pains, good things, hard things with respect to your tool, because all of you were using different tools. And then, for example, suppose that you were doing a SQL Server, but another group using Teradata, for example, and maybe you can share your problems that you had with SQL Server, and the people with doing Teradata have problems with the Teradata, so at least we heard at least once on our life how can we build data warehouses on different tools. So who would like to express his or her opinions on what they have learned during this project? Nicole, thank you for being so active in.
I think the first pain points and lessons learned is do not trust that the TPCDS tools will work with no errors.
So please restate it again for those that.
So basically, when we were generating the data, we found errors upon generating the data. There was nothing special about the two, like the language, the database system that we were using. The tools that were provided by TPCDS just didn't work, and we weren't sure why. We had to go through a lot of Googling to find out. Some of them we figured they were just randomly appearing, so we just ran it enough times so that they wouldn't appear. So yeah, that's the first thing, like don't trust it to work on the first time.
Or, I mean, maybe this is the pain, some pain that you experience, and what are the lessons you learn? What did you learn with this exercise? You are in the same group? No, Nicole and you. Maybe Andres, help Nicole.
Just following up on Nicole's comment, like that's completely true. Well, that we experienced that not everything was working, but especially, and this is also like merging with a comment that you did in class, is that when we started going like to higher scale factors, we started encountering a lot of problems. And where things like, at least in our case, that we felt like we're like a little bit like out of random, that things stopped working. So it was a good idea, like at some point, like to start like having like very tiny data sets just to test things and to make sure that they actually work. Because debugging when you're trying to do a benchmark of a lot of data is difficult to do because you have to wait for the result in order to know if the changes that you implemented are actually correct.
So, according, if I summarize your learning experiences when you are working with big data, start as small as possible immediately to do not waste time, because probably you were waiting 2 days. Some of you waiting 2 days to get the first run of the exercises, and then suddenly nothing was happening. So, my first lesson would be that. When we are manipulating big data, start as small as possible immediately. Other lessons?
One thing that we learned is there was one query that wasn't working, and I mean it was taking half an hour to run while the others ran in less than a minute. And then we learned that we could use the query analyzer from SQL Server, and it would provide us insights on what was going on and why it was taking so long. And we were able to, Diogo's idea was to use to explicitly say a hash join instead of just a join, and it solved it instantly. So the optimizer didn't have to choose what type of join to do, and it ran just as well as the other ones.
And how did you find that? How did you find that it was the hash join that the one that needed?
The query analyzer, we saw that the join was the one that was taking too much time.
So that's a nice experience indeed. Now, when you are working with with bigger data, of course, working the same query, the smaller data is easier. You will not find a few milliseconds more unless you don't you don't feel the difference. But when you have huge amounts of data, then this small optimization is essential. Other experience that you have learned here, maybe in other tools. What were the problems in other tools? Are all the queries immediately worked in other tools, or?
Well, we have some problems with developer queries because we did it from the
Could you recall me your tool?
Google View queries.
So can you, maybe can I ask you, what is the main difference for those that you don't understand what is Google BigQuery? What is Google BigQuery with respect to relational databases?
It's almost the same, but not in the end because it's due to do all up, so online analytics. So there we don't have any constraints like primary keys or the foreign keys. So the goal is to do only reading, to do as fast as possible. So for example, BCS provides Esteban schema to load into our database. So we have to modify the schema to deleting all the primary keys, for example.
Can we hear what his?
So we have to do a lot of adaptation to make it work. And there were also a lot of queries, like 20 maybe, or 25 that didn't work immediately. So we did all the adaptations. So I think it was maybe harder than choosing a dialect that is immediately supported by TCDS. I don't know, the server, for example. Because there's a list of the PMS that TCDS supports. And I think maybe it would be easier to follow.
But are you happy with the experience with Google Bigtable?
Yes, we are happy because in the end it's really fast.
Can we have silence, please?
So we have to disable, for example, cache on the cache, memory cache, because when we executed the same query multiple times, BigQuery had done some optimization in order to go faster. So all this has to be managed in the queries. But we didn't really have execution times of other DBMS, so it was maybe hard to compare them. But we felt that it was really fast.
Sorry, one question related to that. How much did you deactivate the cache between several executions? How did you cope with this problem? The problem is transversal to any database. The first time you have a query, you need to bring the data from disk. Typically, it lands in a cache. The other times that you use this query, you don't need to go to the disk because the data is already on the cache. They decide to disallow the cache to make really more realistic time for the execution. Did all of us do the same? No?
At the end, I think that the main focus was for us to see the growth of the running time. So we didn't need really to work the real time. We learned running this query on a real life situation. So we just decided to remove the first query, the first round of all the queries, and then use an average of the others.
You were wanting to say something, Andres?
I was having just a question for them because out of curiosity, but I don't know if we're following through this conversation. What we did was something similar to what you did as well, like did several runs and then average. use like a trial or something in order to?
Yes, there was a trial like for 3 months. But
Okay.
but you have to give your credit card or PayPal, but they won't charge you anything because they have free credit. They give you like $250 or free credit to use. And I mean it's hard to use it.
To use it, yeah.
I mean I think we didn't maybe we used $1 or what also 250.
But you know, maybe you have received an email from myself when I finally asked for you to have access to the Google Cloud platform. You have access now, and then if I understand well from our previous experience from previous years, when you can redeem, you ask additional credits if you expose your credit. But you can already try this. If you are interested, you can try on Google Cloud Platform to begin understanding how do you work with cloud platforms. Other,
Sorry, I have another follow-up question. Were you saying that for some of your queries you had to disable them because the functions simply didn't exist in Google Big Data? You had- Did you say that there was about 25 queries that you were not able to complete because the functions did not exist? And could you give some examples of like what exactly didn't exist?
Yes, okay. So, for example, this is a simple example. There is a query where, I mean, this was a query that was easy to correct, but we have a data, a simple data, for example, 20 of January 2002, and then we have an addition of, for example, 14 days. And this we have a big error saying that there is a problem in this operation. So all we have to do is to save the 14 days to add them ourselves in the data before, for example. So this is absolutely very correct. But there is, for example, another thing. For example, BigQuery doesn't have like union, it's only like union or intersect it was, but only intersect all. So we have to think a little how to overcome the problem. And we had some luck also because we found a page where some of the queries were already adapted from TCDS to Google Query. So that was.
So it was a problem of trying to create that the intent of PCDS, for example, was that they want you to do maybe it one way, and to find the Google big table way to do it that replicates what PCDS is intended to do. Yeah.
there was a question here.
No, I just wanted to share my experience.
Can maybe remove your mask,
Yeah.
otherwise it will be difficult to hear you.
Okay, for us it was MariaDB.
MariaDB, so?
Yeah, so there was one particular query which was taking like longer for execution, like longer as in 1 day, 6 hours, just for one query.
1 day for the scale factor 1 or?
For scale factor 1.
Uh-huh.
And we were surprised like how are we having it such a long duration for a query execution. But then later we tried to optimize it and we used indexing and then we were able to execute that query. So that was a like nice query optimization experience that we had. Plus there was other like observation that even we tried like doing a comparative study, just like for safety side. Firstly we thought we'll try to run it on 2 machines, but in the end we observed that for the execution on one machine it was happening because the configurations were different. It was executing at a much higher speed than that on the other machine. So it was even machine dependent rather than just being the scaling factor that we were testing.
So here we are tackling another interesting question. With the same tool, we need to optimize already settings of the database, of the machine, etc., in order to optimize the query. So this is an important factor. So even if you are expert on SQL Server, you need to adapt your configuration to get the most of your machine and SQL Server together. Other guys experience, yes?
For us, like there was some one interesting thing was that we checked it across different chip architectures. For example, I was using M1, like ARM-based processor, and one of my colleagues was using Intel-based, and he has like performed like for spec-wise, his system was better, but it took like for me it was taking maybe an hour, and for him it was like 3 hours for the same scale factor, and everything's configuration was same, everything was same, but the instruction set will like.
That's interesting. So I never experienced that. So look at this, having a different processor within your machine, even change with the same scale, with the same data set and the same specs of the machine. So it's an interesting observation I never experienced myself. Thank you. Other experiences? So now let's analyze, and then I will leave you to go. Please go log in because the login. If you are logged in, this is the important part. This takes time, but in the meantime, how have you already had the time at least to see what is your next challenge for the TPCDI project?
Yes, we're gonna figure out how many beers we can drink to celebrate TPCDS.
So at least you know what are the maybe Andres, can you explain in your own words what we are trying to guess to do to learn into the next project?
Yeah, I'm not an expert by any means. I have just an idea of what I've read, but I know it's going to be more related to the ETL process, more related to refreshing the data and that kind of stuff. So it's probably going to be a little bit more challenging than what we have right now.
So.
In my opinion.
So the idea is that until now you have, you get a little bit problems to get the TPCDS schema enter into your particular tools. We discussed with the Google table example. It is not necessarily the matching exactly the same thing. You need to make things matching, but nevertheless you were in a protected playground. Because more or less you have a fixed schema, and then out of that there are many blogs talking about that. Now we have you will be basically on the forest. You will not have many tools that help you, many blogs that will help you. You have input data in many formats, and then of course you will be getting this data from the TPCDI. But basically you have news feeds, you have CSV files, you have XML files, and you have many different kinds of things. And there is much more possible variation how you could enter all these different data sets which are not necessarily coherent between them and end up with the database schema that you already know. So the range of possibilities, how you start with your input data to the final database that you were using. You need to arrive to the starting point of the PTCDS, meaning you have a full database field at the end of the project. You need to obtain the same database from which you started the PTCDS, out of CSV file, XML files, and etc. And so there is a long process to make all this huge amount of data land in the same, and then you have the immediately way to test whether your ETL process are okay. You keep your previous database, you solve your problem, and you have some database, and you need to compare that the tables have exactly the same content out of this, and then therefore you need to choose the right tool for doing that. All these tools are by definition horrible, bad, performance-wise they will not perform. So then you will need to delve into the real problems of making data coming from multiple sources to arrive to the data warehouse. And then you will experience, my personal experience, I would rather do all this processing PL SQL. And I'm doing that orders of magnitude faster than whatever ETL tool, including integration services from Microsoft, or what is your preferred ETL tool? What ETL tool have you been using?
Data Factory.
Sorry?
The one from Azure, Data Factory.
Data Factory could be. I never used that, but which tools are you planning to use for this ETL task?
We have never used.
Never used. So you need to find one tool for doing that, extracting all this data from your CSV file and XML files and land it somehow with multiple steps in the manipulation. You need to take this data from this file, this data from this file, and make the two end up in the same line, the same row in your final table. And probably one data will not be coherent with the other. Which one you will take, you choose. So this is a much more challenging problem. I would suggest to at least start immediately, because it will be, you will have much more problems than the protected playground that you were playing around with the TPCDS. And of course, start little. Store, instead of having to ingest the 1 megabyte file of CSV, take the first 100 lines and make sure that these 100 lines with the 100 first XML definitions of the other file end up with the right, at the right place in the right table. And then little by little increase, begin feeding the second table. And then making whether there is a good referential integrity between the two tables. So start little, as small as possible, and one problem at a time. And verify each step of the process, whether you need to do a join, but you don't have, one possibility is to do all the processing inside the database. You can input the CSV file into your table, in one table, the XML file in another table, and then you are able to do a join. And then you can begin one step further, but verify each process, because it is too late when you are building all the pipeline until the data ended into your table, and then verify half of the lines are bad, or half of the lines are missing. Which of the 10 steps were failing? So verify each step at a time to be able to do this processing correctly. Okay, so this is your next pain or learning experience, call it as you want, for the next until December. Yes?
Do you have any recommendations on what tools we should use?
Up to you. Then if you are able to do SQL programming, I would definitely, but if you are a fan of, they are very famous tool, I don't have the names here, man. Even Java-based tools, I even have a paper on that, doing the performance in SQL queries, and 2 or 3 of these famous tools. I will immediately look this reference, I will show it there. We have orders of magnitude better in simple SQL. So if you are comfortable programming in SQL, do it in SQL. If you are comfortable doing in PHP or Java or whatever, do it in whatever language. But try, begin already experimenting a little bit of the problem, and then choosing your tool or your strategy immediately, and then stick to this strategy for the rest of the project. In your case, you can use, for example, integration services. Integration services is one of the best tools, but nevertheless, it's not as good. What is the idea? I need my PC, I will bring it. The idea is that all these tools need to do joins. And you mentioned, Nicole, hash join. A simple hash join will be orders of magnitude better than a normal join. Imagine if all these tools are doing nested loops. Take one record from this file, take another record from this file, and merge it. So this is a join that by definition with nested loop you will never arrive to the same performance as a internal join into the database. So please, I mean, in your interest, even if you are only investing 1 day, invest it now, this 1 day, to explore, decide the tools, understand the problem, and then you plan your task whenever you want. But you need to start exploring now to get the idea of the problem and to plan how much time do you need for this project. Okay? So today is this exercise. This exercise is supposed to be self-explanatory. I'm allowed to answer all your questions. I even asked my system admin give the same pack of files, and he was able to do exactly that. He doesn't know anything about data warehouses, so supposedly it's a self journey that you can do yourself. But I will be here helping you answering your questions. You have already a question, Vlada? Of course, please tell me.
I have no question, I have a problem.
Uh-huh. But have you, where did you win? But let me, did you use a new data source view? I don't see a data source view, new data source view. And then, okay.
Which application are we using? Like what application do I need?
You need to open Visual Studio.
Thank you.
But you didn't have put back, please. You need to put all these tables and then select it, yes, or select it all. Okay. And then you have your. So let me explain what happened here. You have one relational database which is accessible through SQL Server. Now we are trying. You were doing the TPCDS on relational database or similar. Now we are going to OLAP. So we are building Cube on top of this database. So you have a Northwind database from which you are importing the data, which is a traditional relational database. We are building a Cube on top of that using analysis services, which is a package layer on top of SQL Server. So if you want, you can even, I would suggest to open your SQL Server database using Management Studio. SQL Server Management Studio, if you find it there somewhere, you can open this database and see the traditional relational database that on which you can build SQL queries to understand where is the different, how the cube connects to the database. In the meantime, I'll bring my PC.
You're creating a data source? You're creating a data source? This is the problem. Yes, even that is the problem. Are you creating a data source on existing or new connection or based on another object? Just find it. Yeah, not that. After data source. New data source. Now this will be
Ya voy, un momentito.
okay.
Minutes. I will come to you as soon as possible. How come it doesn't?
Nothing for now. I'm testing the connection. Let's see. Were you able to connect? How come? Were you able to see it in the drop down?
No, this is reboot. Did you reboot by chance? Yes, of course.
And I guess at some moment I should click
Yeah.
and choose
The Windows.
Windows. I forgot which.
But it will immediately show you. Maybe you can switch to that.
Yeah, because I signed up to Windows, but when I was trying to connect to the server, it says that I am not logged in. And that I'm using the temporary data.
Please try this. I think I have a problem with the projector. was a question here. But let's see where. And which did you put the right password here? I mean, what kind of let's see. Yeah, I need to close this. And then properties.
Done?
No, no, it is here. What did you put your ULB account? Where is it? No, you need to choose to write the project. Because you cannot do on the local host, you need to do here solution build. Let's see configuration somewhere here. You need to define your local host data. Now maybe here properties. Where it was deploy in not the local host but on the same server. Edit database name. No. Properties. Somewhere here it should be deployment. Yes, you need to put the right server there, which is the same server in which remote server you are SQL with. Try that one. Try this. So if you are having problems to deploy your database because you are trying to deploy it in localhost, and localhost there is no database server on the localhost. I mean your local machine, your PC in front of you. So you need to deploy it on the machine on the same server, which is the one you connected, which is with -SQL-edu, and then normally with that you can deploy it on your. And then of course you need to have a right. Do not use multidimensional project 1 because you will be rewriting someone else's database. So please choose the right name for which is related to your login or your name or random number, but use a different deployment database for each group. So please say no and change your name of your multidimensional project to rename. Rename and then put your login or something like this. Try this, please.
Server name would be
No, this one. Question? will look for another projector. Is it deploying now?
Because it here shows me the override database software.
Ah, yes, it is working. I coming. Allow me a few minutes to resolve this issue. So now that I have a projector working, maybe I will just finalize the thing that we were doing. I was explaining a little bit. So this is an article we published with a couple of, last year with a PhD student. We were discussing how PLSQL, traditional SQL solution for the TPCDI with Pentaho, with Talend, went performed with scale factor 3, scale factor 5, and scale factor 10. And you will discover that there are 3 different ways to do the TPCDI. Historical is the first time you load it, and then you find an incremental with a first batch and then a second batch that you add later. But basically, look at this. If you compare at this large scale factor, PLSQL took 2 hours and Pentaho which is a well-known tool, 25 hours. Or Talent, which is a well-known tool, also take 9 hours for doing exactly the same loading of all the files into the TPCDS schema that you were loading. And then, so you know that there is a considerably way to say that SQL is much better than Pentaho and than Talent. So this is the kind of thing, you know, I can give you send you the PDF after this. Yes?
It's actually regarding that, does it say like how much, what scale factor was it or anything?
I don't remember the details. Probably they are here at the beginning of the article. Yes, and in addition, there were slowly changing dimensions that we need to implement. Somewhere here it should be, yes, the TPCDI benchmark. I don't remember. I mean, we use the scale factor explicitly stated into the TPCDI specifications. So I will send you this. You might just, it's available through the library. So the article is called, maybe you can even download it. Design and implementation of ETL process using BPMN and relational algebra. And we were using the TPCDI as example. And then so you have an introduction, a small introduction of that, of the problem here. And then you can build your solution on top of that. So now I can answer your queries, your question. No, this is, sorry, may I remove it so I'm sure?
I have to connect
Yes,
to the
so here we are adding new data source. Let me see. Okay, perfect. So new. Then please type there your data source. So it is SQL with this thing that is with SQL. So this is the server, and on this is a relational database server, and on top of it you need to find one database, which is called in this case. And then
I thought it was just the.
but and then next, and then please type your login. You will be login and password. I'm coming, Adam. Yeah. No, this is just a connection with login password, and then you need to go to the views, new data source views, and then you see, are you using this connection? Yes, and then you see the tables that are there. And you choose to add all these tables there, and then you see the link between these tables. Question here, Adam? Yes, but the idea is that you deploy properties not on the local server, so deployments, you are saying I use the have the problems. Yeah.
We can't double click it. We need to right click on it. Okay.
Here, let me just click around for a second. No, because deploy leads to the air. Use comments. Yeah. This is here, we change to the woods.
But the problem
Share the word.
were you able to deploy or not?
Oh, I don't know. I just started sharing the solution first.
That should be working. I don't know how.
It is
Do
not
you
working.
mind that I start from scratch? Delete. Let me start again. See whether there is a connection So let me try with the data source, new data source.
Okay.
No, it like to create and then in this database, this server, this database, because it is the one having the data, it is relational database on which we are building our queue. So next, please type your login name again. Finish. Let's see.
But the server is not running.
Where? Yes, underscore. DW.
Yeah, but you need to install all the package, SQL Server and Analysis Server.
Simple underscore that, right?
But it's not
Still it is not
to
happening.
have space on this, but about it takes a lot. I'm trying to think about the problem. Maybe I should just explain it. You were able to do deployment or not?
Yes.
But then can you please try to help them? They cannot deploy. They cannot deploy, so while in the meantime, maybe you can answer your question. What the problem is? Uh-huh. So the hierarchy is relationship. Let me go dimension structure. So you need to put what category ID. What are the so category ID maybe you can already put category ID here and one category ID there is okay. Then we can go to attribute relations and then how come it is like new
Is it possible that there's a naming where they first into the server, and if we're all using the same name, there's some issue?
I mean, the target database should be different, but the server is the only, there is only one. I mean, your solution, your name at the top of the,
Should be different?
Not happening. Then
yes. I don't know, let's start with this, so I have product ID first, and then so now if I go here, then I can see it. Yeah.
And the database name is supposed to be same or like
Maybe I can explain, I mean, in my local, since some of you are having problems with connectivity, I can explain what we are, but I see that here we have a problem of resolution. Wow. I need to reduce the resolution of the screen, but I don't know how to do it in Windows. Can you help me with that? How to do it? So I. Sorry, we put. I think this would. Okay. Thank you. So, as I mentioned, we have here SQL Server Management Studio. So I'm having a bigger version of this database, which is the one we use for the book as a running example is the Northwind Data Warehouse, which is our in SQL Server one old database that came with the tool is the Northwind database. This is an operational database. Then we transform this operational database into a Northwind data warehouse that has these categories. These tables: category, city, continent, country, customers, and a fact table. So let me try to show you things that we are doing. Let me have here. I don't think I don't. So we have tables here. This is a relational database as always. If I put, let me see, query, query, where is the query here? How do I put a query here? New query, this is the one. So if I do select star, I don't want properties, I want queries. And with this resolution, I cannot do this one. Is what select star from categories, for example, category. Let me go do it smaller here. And execute. So I have a traditional relational database with all these tables here. What we are doing now, this is SQL Server Management Studio. What we are doing here is to use the data relational source that is below and build a cube out of that. So using SQL terminology, Solution Explorer, suppose that I want to click this, remove this. So we need to first do the connectivity. Data sources is the way that SQL Server says, which is the the database server providing the relational data warehouse, which is the password, etc. All the connectivity is there. Out of that, there is these views that you have already. In my case, there is a lot more views, but you can extract pieces of this relational data warehouse. You are not necessarily importing all the tables. You can say I have only a small views for the sales department or for the marketing department. This is where you put your views. Then out of these views, which is a relational, of course I need to do probably like this. I remove properties, and then I don't have a view defined yet for the moment. Out of this view, you have your cube. Let me. This is a real cube in the OLAP sense. So, for example, in this cube, we have two fact tables, the sales fact table with these measures, and we have all these dimensions by product, supplier, order date, due date, customer, city, etc. So we are really transforming this relational table into a cube, and this is done internally at the SQL Server Analysis Service. So SQL Server, plain SQL Server is a relational database. On top of that, we are building the cube. And on this cube, typically we can express MDX queries. So if you are addressing this relational database, you are using SQL. If you are addressing the cube, you are using either MDX or DAX, that are the two languages used for the cube. And then you need to define, I don't know, let me see whether we have this. The problem is with this resolution, I'm not able to do much. But yes, I look at this. I have the cube, and as you have seen, in the cube, the blue are the fact tables, and the yellow are the the blue are the dimension tables. The yellow is the cube. And then look at this. The cubes is related to the shipper dimension, to the supplier, etc. In particular, there is, in this particular example, there is a many-to-many relationship between the employee and the cities. So because the tools are not very smart for coping with many-to-many dimensions, then for these many-to-many dimensions, you need to define it as a fact table somehow. Even if it is not really a fact table, you need to define it as a fact table in the definition of your cube, and then you can avoid all this double counting problem that we have been discussing. This is the only way to make a SQL server understand this is a many-to-many dimensions, and they need to take care of the double counting problem. And then when you have all this cube, then you can define partitions, KPIs, calculations, etc., etc. But do you understand the two layers? On the one layer, you have your relational database, and then this is the source of data, but you don't have hierarchy, you don't know. At this level, you are simple tables, and you cannot speak about dimension, hierarchies, fact, and etc. This is the language that you use for the another layer, which is the cube layer, and for the cube layer, you need another tool, which is the analysis services. Now that we have seen that, you understood that your TPCDS, you have done it at the relational database level, but you can build a cube using on top of the TPCDS, the data warehouse. But for that, you need SQL Server analysis services, or you need other tools from other manufacturers to build a cube. And this cube, of course, will also, you need to define which will be the materialized views and all these kind of things that are typical of a data warehouse. So you get the idea of the two layers of the relational database on one sense, the cube on the other sense. So going back to the problem, no, this is a disaster. So I cannot show it here, but you get the idea. In the slides, we show the first layer is the data source, the second layer is the relational data warehouse, in the third layer is the cube, and in the fourth layer are the user program for doing analysis, data mining, reporting, and etc. So now we are tackling the cube layer, the data cube layer. Get the,
So the ER diagram that we are seeing previously, that is roll up, right? We have relation between tables, we have stacked and dimension.
I didn't really understood all your question. Can you please restate them?
There are like two things that we studied. One is roll up, one is multi-dimensional roll up. So when we are deploying the cube, is it containing already aggregated values of the dimensions, or is it like a basic level, like unit level?
So this is the right question we need to ask. For the moment, we are just building the cube and understanding that we address this cube by many multiple dimensions. Then when you need to deploy this cube and then do the traditional operations on it, some operations will be not fast enough. For this, you will need to do materialized views or make the system pre-compute some of them. If the system is smart enough and your data is not so big, they do this automatically. But as soon as you have large amounts of data, you need to help the data cube tool to say, I need this materialized view because I'm using this very often.
when we build cube, it is at the basic level, nothing is aggregated. And we have
No, then you can do aggregation and then do pivot tables. If you know what I mean with pivot table, the same that pivot table you use in Excel. Let me try to find
Does the cube itself still retain the original raw information, or when we use the word cube, are we referring to a product that's only aggregated values at some level?
No, you have your base level, and then that will be the aggregation of the fact table, but they have easy ways to aggregate by date, by customer and client, whatever.
Okay.
So you have already these capabilities to do this dimensional addressing the cube in dimensional terms.
So it's like I do end up with like a pre-calculated, when we're doing our roll-up by functions and those, when we're using those functions, this cube is pre-calculating those aggregations.
Let me see whether I have a problem with the projector, but let me see whether nevertheless I can show you. Yes, if I zoom enough, I can do that. Let me go to the right. I need to do some querying. I will look for some queries. Here I'm already talking DAX. No, let me go example of DAX query so you understand why. Let me find the right control home. So for example, you can address the same queries either in DAX or in MDX or in SQL. Let me try to give examples of that. MDX, I have it here. I need to chapter 7. So here, if I am able to do that, this is a disaster, this projector. Please allow me 2 seconds to have a better way to show you that. Control L. So look at, for example, for the same query, total sales amount per customer year and product category. So look at this, how we have a cube sales. And then look at, I want the year and the children. So this is our keyword for MDX, saying what is the children of year. I have semester. I want for the customer, company name, the children, and then I will obtain, I will measure show the measured sales amount. Let me try to find exactly the same query, Control C, Control F, Control V, the same query in DAX. So we have the measure is sales amount. We are going to sum the sales amount, and we will say analyze on one cent the customer, and the other dimension the year, and third dimension product name, and order by. So this is one way to explain the same query in DAX. And again, the same query in SQL. Oh, I did it one more. The same query in SQL is like this. But of course, we are addressing 2 different tools. This you will use when you address your relational database. DAX and MDX, you will be addressing your cube in using analysis services. You get the idea? I know that in these small 2 hours you are not able to do all this, but you can have a look at these chapters in our book to understand how to build your cube. I will send you after the lecture the whole that Northwind data cube. I put it on the Université Virtuelle. So you can open the chapter 5 and 6 and the book and try to redo all this. Let me show you. It's already in the book, so you can do it yourself on your PC or come here and do it. Install your database here. Let me try to find the right. So I was able. I do look at this. Can't escape. So you can define, and here it is, all the steps to define your, I will show you soon. So the same thing we are doing in this exercise here, you can repeat it using the chapter of this book. I explain here the relational database. This is my view, with a little bit more tables than those that are there. I can even have, look at this, there is a many-to-many dimension between employees and cities. So this is a bridge table in the relational database that I need to transform it into a fact into the SQL Server analysis services. I need to compute derived columns here, for example, for convert add a quarter and semester to add a quarter name and semester name to the database. So the idea is why we need to do that. You import your database, operational database, into the cube. This cube is not you don't have write access into the operational database. So you import the operational database as it is. And then you can already modify at the data source view, add new things, remove tables, join tables, and modify. Already target the data source view that a little bit is closer to your final data warehouse schema. Then when you have your final data warehouse scheme, you have several kinds of dimensions that are explained there. And here we have, we define for example, the categories, products and category dimension. And then we can see here the categories and all the products inside this category. Then you have the temporal dimension. I explain how to do the temporal aggregation. Of course, there is a single table, but you need to define this hierarchy for defining that in this data cube, I will be interested in go by year, by semester, by quarter. So all this aggregation, you are already defining the aggregation path of your data cube. Then you need to define all these kind of things, the relationship from the functional dependencies for those that understand this term. A date has a single month has a single quarter is related to a single semester. So all these functional dependence you need to explicitly state it into your cube. And then you are able to deploy your cube like this and then you need to do a little tricks to order this all this is explained into the book. How do you order, not by alphabetical order, because by definition all the members are in alphabetical order, and then you can put it in normal order, but for this you need to take the numerical value of the month and make this numerical value of the month of the order in which the elements of the quarter are sorted. So you need a lot of customization to make this cube work. And then after that, you need to take care of the recursive dimension. For example, in the recursive dimension, there are employees who manage other employees, and then define that properly in order to be able to see the hierarchies of your recursive dimensions. And out of that, you can build a cube with, look at this, the cube is there with the measures, the dimensions, the full cube is there. And then I define, look at this, I need to define here how to, this is a many-to-many relations to indicate that to analysis services. Compute additional measures. I can look at this. I'm computing a new derived measure net amount, which will be the sales amount minus the freight. And then I can able to do this kind of, for those that asking aggregations, maybe Adam or Andres, you are asking an aggregation. When I define the cube, I can obtain this kind of things very easily, because I say I'm going to analyze by location, I don't know whether this is customer or location of the customer or location of the, yes, that will be location of the customer, and by year, and then you can go roll up and drill down your data, and you can even do here maps like the one it is shown a little bit later, things like this, in which this is in Power BI, but for Power BI we need to use the tabular model, which we are not yet looking now. For the moment you are using the analysis services can work in two modes. In the old traditional way, multidimensional mode, and for that we're using MDX. And then recently they use another model, which is the tabular model, and for the tabular model you need to use DAX. So there are two views on top of the same relational database. And for example, nowadays the most popular tool is Power BI with the tabular model. So basically Microsoft killed MDX, its own product MDX and the multidimensional model, and now is favoring Power BI and the DAX. But the idea is that you can have a data warehouse and cube view on top of relational data store. You get the overall idea what, so now you understand what is the next level of the layer architecture that we have been discussing until now. Question? Okay. So all this is in the book. If you are interested, you can, I will immediately after the lecture put on the full database. So if you want, you can download this database, install it in your account here, or you install it in your PC and do all this exercise yourself. It's a little bit more elaborated than this because we cover many other customization details of your cube. Question? Okay. Okay, so then I will continue solving the problems people have here.
I did this thing by going in properties and deployment and this and this. Even applied the changes, but still my cube is not getting deployed.
Because there was one mistake.
Project 1.
It's
The database
ED.
name.
Oh.
Like capital.
The database name should be simple new DW. Yeah? Then you're rewriting your database.
Just reading it. We only have the read permission. ये अंधेरा हो गया क्या? Process.
It's writing.
Oh,
I think it's writing.
thank you.
Not writing.
Okay, just run.
Can I see? Okay, run. Succeeded. Thank you then. And this is on record.
I'll play it in a loop.
So, make then you in every data warehouse you need to put
Then it's done. Then what to do?
Nothing.
I think yes, create hierarchy. So here customer dimension. Maybe if I go to data dimension. Duplicate, yes, so this is the problem. Of course, you have to this is explained a little bit in the book because you need to define that the key when you are saying semester 2 of this year, so say semester 2, let me recall how I solved this. This is not explained there. So let me already have the same process with the product dimension. So we have here, we have a category ID, product ID. Suppose that I do this. Suppose that I do this. Process proceeded. So
Did you run for it? Did you run for it? Yeah. What are you doing? Now I'm going to the garden. How are you doing that? Where is it mentioned?
You modified the software.
After doing that, click double click